This is I'm Sark, and in this video we are looking at integration by parts. So the general formula that you have to learn is uv minus the integral of v times by du over dx dx. So that is what we will have to do each time we do an integration by parts. And we use an integration by parts when you have two functions multiplied by each other, and usually one of the functions will differentiate to make a constant. So for example, in this one we have 1 minus 3x is times by cos 4x. So in order to choose what is going to be u, we choose the one which would differentiate to make a constant. And in this case, it's 1 minus 3x. So therefore, we say that u is equal to 1 minus 3x. And then instead of v, we actually put dv over dx, and in this case that is equal to cos 4x. So therefore we have to differentiate this, so du over dx, that is going to be equal to minus 3. Obviously 1's already a constant, that's not going to differentiate to anything, and then minus 3x differentiates to give minus 3. And then dv over dx, this time we're going to have to integrate it to get v, and this means that v is equal to a quarter, and that's because we have a 4x here. When we're integrating, it's going to be 1 divided by a quarter because we have 1 in front of this. Then it's going to be sine because cos differentiates to give, integrates to give sine, and then 4x. So now we have each of these. Now we just have to put it into this. So let's see, we have the uv, and that is going to be equal to a quarter sine 4x and then we will put here 1 minus 3x. Then we have to minus integral of v is here, so a quarter sine 4x, and that's going to be times by du over dx, so minus 3. And that's why it has to go and be a constant, otherwise we would have to do another differentiation by parts. And we will look at an example where this doesn't necessarily go to a constant and we have to do it twice. But for this time it is a constant, so therefore we're doing minus 3 over 4 sine 4x. So the final step, we still haven't integrated that, so we can rewrite this as a quarter, and just to neaten it up we'll put the 1 minus 3x first, and then sine 4x, and this is going to go to minus 3 over 16, and that is because we've got the 4 there, that's going to be divided, so 3 quarters, minus 3 quarters divided by 4, it's going to be minus 3 over 16 cos 4x, and then finally we just have to add that constant, add c. So the next question we have has a ln 3x in, and so this time this one is going to be u. So therefore what we say is u is equal to ln 3x. So that means that dv over dx is going to be equal to 1 over x squared, which is also equal to x to the minus 2. So therefore du over dx is just going to be equal to 1 over x, and then v is going to be equal to minus x to the minus 1, which we can also write as minus 1 over x. So therefore we're using that same formula. So u times v is going to be equal to ln 3x times by minus 1 over x. That is going to be minus ln 3x divided by x. That's because we have the minus 1 over x times by ln 3x. The ln 3x is just going to go to the numerator times by that 1, and that's what we're left with. Then we're going to have minus the integral of these two times together. 1 over x times by minus 1 over x. That is therefore equal to minus ln 3x over x, and then minusing that is going to be minus the integral of minus 1 over x squared. That can also be minus x to the minus 2. Easier to put in this form, as it's then easier to integrate that. So therefore, what we're left with is minus ln 3x over x minus 1 over x, as that is what that integrates to, and then a plus c. So the next question is slightly more difficult because we're going to have to do integration by parts twice. And this is because we have an x squared which isn't going to differentiate to give a constant, but after 2 times it will differentiate to give a constant. So this one says x squared cos 3x. So therefore we are going to use u as our x squared, because if we used u as our cos 3x, it would never go into a constant. So therefore we say that u is equal to x squared, and dv over dx is equal to cos 3x. So therefore du over dx is going to be equal to 2x. V, on the other hand, we integrate that, we're going to get a third sine 3x. So therefore, we're going to put those together, the x squared times by a third sine 3x, and we're going to get a third x squared sine 3x. Then we're going to be minusing the integral, and here we have 2x, that's going to be times by a third sine 3x. But of course we can't integrate this without doing integration by parts another time. So now for the second thing, I'll change colour to show that this is our second integration by parts. So we have 2x, a third sine 3x, so this time we have u is equal to 2x, and dv over dx is equal to a third sine 3x. So therefore du over dx is going to be equal to 2. V, so sine will differentiate to integrate to give minus cos, and then a third divided by 3, so we're going to have minus 1/9 cos 3x. Now remember, we will always have to use this, so I'm just going to circle this to make sure that we're remembering it. And this is the minus this. So first of all, we're going to start off with minusing, then you got the u times by the minus a ninth cos 3x. But minusing that, we end up going to be getting plus 2 ninths, and then that's going to be x cos 3x. So we have that, and then we're going to be adding. Now this is adding because it would normally be minus, but because we've got a minus sign round here, therefore this is going to turn to adding, and that is going to be integrating minus 2 ninths cos 3x. And that is because what we have is we have the du over dx times by v. So therefore, now we have this, we can put it all together. So we're going to have a third x squared sine 3x add 2 ninths x cos 3x and then finally we have this add this, which is going to end up being, if we integrate this, we're going to that shall go to the sine, so we're going to have minus 2 over 27 sine 3x. And then finally, we just have to remember this constant, so plus c. So that's our final answer for that one. Again, the most important thing to remember here is whether it's negative or positive, as it can get very confusing. So our final question is using limits. And to start this question off, we're going to go exactly the same way as we normally would, yet we are just going to add some limits at the end. So again, we have a ln x here, so therefore we're going to say that u is equal to ln x. That means that v is equal dv over dx, is equal to x squared minus 2x. So therefore du over dx is going to be equal to 1 over x. V is therefore equal, if we integrate this, we're going to get a third x cubed minus x squared. So therefore, we've got uv at the start, so we can say that this is going to be ln x, and then that's going to be a third x cubed minus x squared. That's going to be minus integral, and then here we have this 1 over x, and that shall be times by a third x cubed minus x squared. Obviously though, we can cancel stuff out, so that x we're going to cancel there, and that'll be x squared, and it'll cancel with that. So therefore what we're left with is ln x times by a third x cubed minus x squared minus the integral of a third x squared minus x. So therefore we'll integrate this to get, this will stay exactly the same, ln x a third x cubed minus x squared, and integrating that, what we're going to get is minus 1/9 and then that will be x cubed, and then minus x will differentiate to give minus a half, integrate, sorry, to give minus a half x squared. So now we have to put in limits. So we're going to put a big bracket around this. And then the limits we have are 3 and 1. So it's exactly the same until we start with the limits. And then if we let x equal 3, if x is equal to 3, then a third x cubed minus x squared is going to be equal to 0. So therefore, this is going to be 0. So we can say 0. Then we're going to have minus. And if we put 3 into a ninth x cubed minus a half x squared, what we're going to get is minus 3 over 2. So therefore, that's going to be minus 3 over 2. That's equal to 3 over 2. Then we let x equal 1. Again, if we put 1 into the starting, we're going to get 0. Then we're going to minus that, and then we're going to have 1/9 x, which is basically just going to be 1/9 minus a half. That is equal to minus 7 over 18. So therefore, that's equal to 7 over 18. So then using those limits, what we're going to say is therefore 3 over 2, and then that is going to be minus 7 over 18. That's going to be equal to 10 over 9. So that is how we use limits when looking at integration by parts. So thank you for watching this video and see you soon. Bye.